Okay, last video of the unit before the test. This is the one section that we have between the quiz and the test, and it's all about spheres. Spheres, I know, probably look complicated. They get this crazy curved surface, and how you're going to find the area of that. But really, it's pretty simple. What's most simple about a sphere is really once you measure the radius or the diameter, there's really no other measurements on it. It's not like pyramids and cones and prisms where we had all different kinds of measurements that could be different in different ways. These are actually quite simple when you get down to it. Okay, so this is about surface area and volume of spheres. Notice we didn't say lateral area. There's really no such thing as lateral area. It's different than surface area, so we just call it one thing and we call it surface area because there really isn't a base separate from what I would kind of think of as the walls of this thing. There's just really one surface to deal with. It's called surface area. So first of all, what is a sphere? A sphere, it's called the locus of all points in space that are a given distance from a given point. Okay, so we did, don't let the word locus scare you. When we talked about the definition of circle in two-dimensional stuff, a circle was, where's my pointer? Okay, a circle was the set of all points in a plane that are a set distance away from a center, and that set distance was called the radius, and all the points that could possibly be that same distance away from that center point, that made up that sort of populated the circle. This is the same thing, but instead of being in a plane now, we're in space. So all the points in space that are the same distance away from a given center point make up the sphere. The radius is that distance that they have to be, of course, so that's great. That's just like circle. A chord is a segment that connects any 2 points on the sphere. I don't think we're going to talk about that very much after just this slide, but okay, that's what a chord is. A diameter of a sphere is as you would expect. It goes through the center and it's a line segment. And a tangent to a sphere, also, we're not going to talk about that very much. There's tangent lines, there's tangent planes, there's all kinds of fun stuff if you take higher geometry courses beyond high school, but we're just really going to deal with surface area and volume, and that's all based on radius alone. So here are the two formulas. There's two formulas you will see on this page. There is, whoa, that's a big highlighter pen. That's from the last, there's the sphere surface area, and there's the sphere volume. Okay, I guess you can't really see those now. But those are the two formulas. Now your eyes know where to go. The surface area of the sphere, and these will be on, of course, these will be on the theorem list when it's time to take the test. There's one, there's the other. And notice all they have in them in terms of variables is radius. The rest of it's all there for you. Now, why are they what they are is this discussion I'd love to have with you in class, particularly this volume one. It's really fun. But where do they get surface area? Actually, they get surface area. I think there's one way to easy way to show where they get surface area once you know the volume. I think the volume is easier to get first and then get surface area from there, but we can talk about that in class. 4 pi r squared. Well, part of that sounds familiar, the pi r squared part. Pi r squared you can think of as the area of a cross-section flat circle. If you were to slice this, just like they have pictured here, if you were to slice a sphere right through the center on a plane, you would get this biggest flat circle possible. The biggest flat circle possible is called the great circle, because you don't have to think of it horizontal. You could think of it vertical or some crazy diagonal direction. Anyway, the biggest circle you can draw on a sphere, like if you were going to put a belt around this thing, like an equator or a meridian, or the largest that it can stretch the rubber band, that's called a great circle. And that radius would be the same as the radius of the sphere itself. The area of that flat circle would be pi r squared, and it just so happens it takes exactly 4 of them, by some grand coincidence of the universe, it takes exactly 4 of them to cover the sphere. Now, if you had 4 of those things cut out flat out of some bendable surface, they wouldn't exactly all fit on there perfectly and stay out of each other's way, but it is actually the same amount of total area. The orange peel is 4 times the area of this flat thing if you could cut it in half and use it as a stamp. It takes 4 of those to cover the sphere. Okay, and then the volume of the sphere is the weirdest formula you've probably seen all chapter, which is 4/3 times pi r cubed. You start to memorize that after you've used it 3 or 4 times, but that's the formula for volume of the entire sphere. If you ever cut a sphere in half, like it looks like they did here, a lot of times we deal with hemispheres. They're usually flat. They usually show them like this, like a bowl. They're flat on ones, they have sort of a base, and then they have this hemispherical shape. The volume of that, of course, would just be half of the volume of a sphere, if you ever needed that, or find the full volume of the sphere and cut it in half, just like you would probably think to do anyway. We're ready to do some problems. There's not much to this. It looks like the diameter is 22. That's supposed to be diameter, the way they've shown that there. So guess what? One calculation we have to think about is radius. So the radius is 11. Find the surface area of the sphere and the volume of a hemisphere. Okay. Surface area of the entire sphere. That is, well, we were just told this, it's 4 pi r squared. And all we need for that's radius, 4 pi times 11 squared. That's 121 times 4, which I can't do in my head. Oh, this is so you can't see it, sorry. Oh, that's kind of big, let me fix that. All right, so I get 484 pi. And there's really no reason to simplify that to decimals, but if you really want to, be my guest. Oh, I'm sorry, I forgot the other part of that question, which was then find the volume of a hemisphere. So I'm going to write hemi down here so I know what I'm talking about. Volume of a hemisphere is 1/2, I'll write it this way, 1/2 of the volume of the sphere, which we learned on the last page, is 4/3 pi r cubed. So half times 4/3, that's 2/3, lovely, times pi times the radius cubed. Well, 11 cubed on the calculator, you should have probably seen this in, sorry, move that mouse thing after there. In the last section, 11, this is the exponent button, 3, that's this, I'm supposed to take this times 2/3. I get, well, 2662 over 3. So the best answer I like for this is 2662 over 3 times pi. You can either stick the pi out here, you can put it in the numerator, that's okay too. And again, that's perfectly fine for answers on this test. You don't have to go to decimal land if you don't want to, and I don't want to, and then again. Okay, number 2. Find the surface area and volume of a sphere has a great circle with a circumference of 5 pi. All right, so they're telling you this great circle has a circumference that's 5 pi. Well, you know all the formulas we need. All the formulas we have, they're all in terms of radius. So what's all this crazy circumference talk? I just have to convert from circumference to radius. Remember, circumference was also expressed as pi times d. So I could substitute in pi d for what circumference stands for. So that tells me pi d is 5 pi. That just means 5 is the diameter. Well, I know what to do with that. If the diameter is 5, the radius better be 2.5. Okay, and radius is the one I want for all this stuff. So surface area is 4 pi r squared. It's hard to, I think the hardest part to remember about these formulas is the exponents. 4 pi times 2.5 squared, you can simply put that straight in here. 4 times 2.5 squared, and I know I got to stick a pi on this, so it's exactly 25 pi. There we go. So this is exactly 25 pi. 2.5 squared is like 6 1/4. Yeah, times 4 is 25. Okay, great. And the volume is the weird one, 4/3 pi r cubed. I said before, I think the hardest part to remember about these formulas is that this one carries a square and this one carries a cube. But if you remember, this is about area. In that last section, we were all about similarity and remembering that that was had a square exponent in it for area and a cube exponent in it for volume. At least it's the way you would expect it if you really thought about it. All right, so this is 4/3 times pi times 2.5 cubed. I'll do that on the calculator. What's 2.5 cubed? That's kind of crazy. 2.5 cubed is that times 4/3. I get 20 point. Bleh. You know what? I would really like to have this as a fraction. You know what? I'm just going to educate you guys about fractions. If we go 5 halves, that's the same as 2.5, right? And then we cube that. Great. And then we take that times 4/3. I can get 125 over 6. And if I have 125 over 6, is that the same as what I had a second ago? Yeah, it's the same decimal. I like 125 over 6 better. 20.833 blah, blah, blah is okay too. So 125 over 6 is my favorite, so let's do that. The calculator went straight to, oh, it's not exactly, it's not approximate, it's exactly. The calculator went straight to decimals because there was a 2.5 in there, so if there's already one decimal that's been breached, it automatically goes to decimal land, but I'd rather not go to decimal land. So I shouldn't have called this 2.5. I should have called this 5 halves if I wanted it all fraction-y. And I do, so that'll work. Okay, and notice I did not multiply by pi on the calculator, so I have to leave this pi here. Okay, Find the volume of a sphere that has a surface area of 64 pi. Okay, surface area. They're getting fancy on us. Surface area, they told us, is 4 pi r squared, but now we know that's 64 pi. That equals 4 pi r squared. So I got to solve this for r squared because I need, for r, because then I got to put that in the volume formula, and that takes an r. So let's divide both sides by 4 pi and cancel some of this stuff. Divide both sides of this equation by 4 pi. This becomes 16, and this becomes r squared. Well, then that means r has to be 4. Lovely. Do I have enough room for this still? Volume is 4/3 pi r cubed, which equals, I'll just go on one line here, 4/3 times pi times 4 cubed. 4 cubed, I believe, is 64 again, which is kind of crazy. 4 cubed, yep, times 4/3. That's 256 thirds. 256. You notice we're getting a lot of answers like this that have a fraction times pi. Get used to it. That's going to happen a lot when your formula looks like this. But it's already got a fraction and a pi in it. And that's it. Look at this. 11 minutes. Okay. This is the only section that we're going to cover after the quiz, and then your homework is on this before review day. I will see you in class.